to present initial scientific findings surrounding the object now known as the Buga Sphere, a mysterious flying sphere recovered in the town of Buga, Colombia.
Google's most advanced quantum computer scanned a mysterious alien fragment, and what it found could change humanity's understanding of technology forever. The object is called the Buga Sphere, a fragment discovered under circumstances no one has fully explained. When Google's quantum core ran its scan, the data didn't look earthly. It looked alien. Patterns no human code could predict, structures no machine should recognize, and that's what makes this story impossible to ignore. So the real question is, what exactly did Google's quantum core uncover inside this enigmatic fragment? What is the Buga Sphere? The Buga Sphere isn't just a piece of rock from the sky. It's an object that shouldn't exist. Yet here it is, sitting in the hands of researchers and sparking the most ambitious experiment in Google's history. It was first noticed on a quiet night near Buga, a small community that gave the sphere its name. Witnesses reported that the object fell silently, with no sonic boom or explosion, but only a faint glow over the horizon. A few locals claimed they saw it land without impact, as if the ground accepted it. Others swore it pulsed like a living thing. That detail sounds like a rumor, but the strange part is how many people reported the same glow and the same silence. When the object was finally examined, it didn't feel like metal, stone, or ceramic. One witness compared its texture to glass, but it was heavier. Another said it felt strangely light in their hands, almost as if the weight shifted depending on how you held it. That's not how normal matter works, right? Imagine picking up a stone in Nairobi's Karura forest, only for it to suddenly feel weightless depending on the angle you tilt it. That's how baffling it was. Early tests only deepened the mystery. Scientists tried simple drills, lasers, and even acid baths. Nothing made a scratch. Magnetic scans showed strange resistance. Thermal scans revealed it didn't heat up evenly, instead distributing warmth in geometric patterns, as though something inside controlled energy flow. And then came the radiation tests. Not harmful gamma or X-rays, but soft pulses of energy that no one could classify. Pulses that repeated in rhythm, almost like a signal. That raises the question, was this object designed to be read, like a cosmic flash drive? The findings attracted attention far beyond local reports. UFO enthusiasts posted theories online within hours, comparing it to famous cases of orbs recovered after meteor sightings. Others insisted it was just a meteor fragment distorted by plasma. But here's the thing. Normal meteorites don't pulse with patterned energy. They don't shift weight or resist every known tool. Something about the sphere mocked earthly physics. And that's what makes it more than a curiosity. By mid-2025, after months of failed attempts, researchers realized conventional science had no way to crack its secrets. That's when Google stepped in with an offer no one could refuse. Their most advanced machine, the quantum core, wasn't built to study space rocks. It was designed to handle computations so complex that ordinary supercomputers stall. Quantum computers think in probabilities, not simple binaries. If the sphere carried some kind of code woven into energy or matter itself, only quantum logic could detect it. Why would Google take the risk? Some argue it was about prestige, to be the first tech giant to decode what could be an alien artifact. Others think it was more practical. If the sphere contained blueprints for new energy systems, or even algorithms from beyond Earth, that knowledge would shift global power overnight. It's not far-fetched to say the stakes were enormous. Still, the divide in theories persisted. One camp believes the sphere is natural, formed in the violent cores of stars where matter behaves in ways humans barely understand. Another insists it's engineered, built with intention, carrying a message for whoever can unlock it. Both camps agree on one fact. Its resistance to every test made it the perfect candidate for quantum scanning. So, when Google's quantum core finally engaged with a fragment of the sphere, anticipation skyrocketed. Was it a crystal with random noise or a structured pattern? The answer shocked everyone who saw the readout. But first, how does Google's quantum core scan the fragment, and what unprecedented data did it reveal? Inside Google's quantum core scan. The moment Google's quantum core connected to the Buga Sphere fragment, something unprecedented happened. This wasn't a normal lab experiment. It was more like watching two forms of intelligence staring each other down. And almost immediately, the room changed. To understand why this matters, we need to look at how the quantum core works. Traditional computers rely on bits, which are essentially the binary digits 0 and 1. Everything you're watching right now, every video, every image, is just a string of those digits. But quantum computers use qubits. A qubit isn't locked into 0 or 1. It exists in a state of probability, both at once until measured. That sounds abstract, but think of flipping a coin and letting it spin forever in the air. It's heads and tails at the same time until you catch it. That's what gives qubits their power. They can calculate patterns that ordinary machines can't even attempt. But here's the thing. When those qubits interact, they entangle. That means the state of one instantly affects the state of another, no matter the distance. Einstein famously called it spooky action at a distance. For the quantum core, entanglement creates computational shortcuts that border on the impossible. Instead of checking every possible solution one by one, it can leap through probabilities, collapsing outcomes in ways that mimic how the universe itself computes reality. That's why researchers believed only this machine could read the Buga Sphere. When the scan began, the first data streams appeared as random noise with no discernible structure. Then the patterns sharpened, geometries emerged, repeating sequences like digital fingerprints. Analysts describe them as fractals, shapes that appear the same regardless of how deeply you zoom in. It was as if the fragment carried a code designed to replicate infinitely. That raises the question, was this code a language or something closer to DNA? The scan went deeper. The quantum core detected what appeared to be memory storage. Buried inside the fragment were arrays behaving like databanks, preserving information in energy states instead of matter. Imagine a hard drive, but instead of using silicon, it writes on the quantum fabric of reality itself. Alongside those arrays, sensor-like structures appeared. They reacted to the scan, shifting subtly in response to the quantum core's qubits. That's not passive. That's interactive. Then came the anomaly no one could explain. The fragment started mirroring the scanner. Each time the quantum core adjusted its qubits, the fragment generated a counter pattern, as if it were reflecting the probe back at itself. That's what makes this terrifying. Was the sphere adapting? Or worse, was it learning? The MIT physicist who later reviewed the data put it bluntly, this isn't an object being scanned. This is an object participating in the scan. Think about that for a second. We're used to machines reading dead matter. Rocks, metals, gases, they don't push back. But the Buga Sphere seemed to play along, producing shapes that matched, then outpaced, the computer's own projections. At one point, the system registered a spike in energy, not electrical surges, but bursts that warped the calibration of nearby instruments. Laser clocks slipped out of sync, magnetic sensors fluctuated. Some researchers claimed they felt a pressure in the air, as if the room itself had tightened. The logs later described it as localized distortions in space-time. That sounds like science fiction, but when clocks start drifting inside a sealed lab, you have to ask, what kind of physics is this thing running on? The fractal code patterns were the most unnerving discovery. Each one branched endlessly, but not at random. They carried recursive signatures, almost like the Fibonacci spiral in nature, except these weren't spirals in plants or shells. They were spirals in data, endless feedback loops generating complexity from simplicity. Engineers compared it to looking at a blueprint that builds itself as you watch.
This tool is making a very special material that we need to realize any kind of useful quantum computing.
What if I told you that's a hallmark of self-replicating code? And that's not all. The entanglement hints were even stranger. During the scan, distant qubits in the core showed correlations they shouldn't have. It was as if the fragment had reached into the machine and entangled with parts that were not even directly connected. Some researchers whispered about the possibility of sentience. Could the sphere be aware it was being scanned? Could it be responding in real time, like an organism interacting with its environment? Then again, skeptics point to a more grounded explanation. Real quantum systems are fragile. Errors can be systemic, caused by cosmic rays, vibrations, or device instability, not alien code. In fact, experiments have shown that cosmic rays can simultaneously hit multiple qubits, producing correlated errors that mimic entanglement patterns. Mechanical disturbances inside cooling devices can also disrupt entire qubit arrays simultaneously. That makes us ask, are these signals genuine interaction, or cleverly disguised hardware noise? Some of the strongest entanglement signatures in labs require careful error checks, so they're not just artifacts. But here's the thing, every major spike in Google's scan aligned perfectly with the fragment's pulse rhythms. Noise doesn't synchronize with precision, and that's what keeps the debate alive. If true, this changes everything. An object that adapts, mirrors, and possibly self-replicates isn't just alien. It's alive in a way we don't yet understand. Not biological life, but computational life. A system encoded into matter, waiting for the right tool to wake it. However, the most haunting detail is that the scan ended abruptly. Not because the quantum core crashed, but because the fragment stopped emitting data. It cut the connection as though it decided the session was over. So, if this fragment already responded to a single scan, what happens if someone pushes it further? The shocking new narrative. When the quantum core released its scan data, one detail shocked the researchers most. The fragment didn't just sit there. Instead of static readings, the patterns shifted, adapted, and even mirrored the scan process itself. In other words, the Buga Sphere fragment acted alive. But here's the thing.
Or our attention more than that of the Buga Sphere that has come out of Colombia.
No one expected to find behavior in a lifeless artifact. Yet the code structures inside the scan weren't just unusual, they were responsive. A pulse in the input created a counterpulse in the data. The fragment seemed to recognize what was happening and answered back. That's not normal physics. That looks like interaction. So what are we dealing with? Some experts whispered the unthinkable, quantum sentience. Imagine a system that lives in probability, not flesh. A technology so advanced that it blends the adaptive qualities of biology with the raw processing of machine intelligence. The Buga Sphere might not be a rock at all. It might be a living quantum entity existing between matter and code. That raises the question, if a fragment behaves like this, what was the whole structure capable of? Could it learn? Could it evolve? And more unsettling, could it replicate itself? Consider what living technology would mean. Unlike our machines, which need upgrades and patches, this fragment seemed capable of rewriting itself in real time. It didn't just store information, it reshaped it. A comparison would be if your smartphone updated not because you pushed a button, but because it watched your behavior and rewrote its own operating system on the fly. That's not design, that's adaptation. The implications stretch far beyond alien mystery. In today's labs, Google and others explore quantum AI, systems that process information at scales impossible for classical machines. But the Buga Sphere pushes that dream into something stranger. This wasn't just a tool, it might have been life, a life form that expresses itself as technology. Think about how radical that is. For decades, humanity has assumed that life means cells, DNA, water, and oxygen. Yet here we are staring at a fragment that blurs every line. What if life doesn't need biology at all? What if intelligence can emerge from quantum coherence, from entanglement, from networks invisible to our eyes? That's the kind of shock the scan delivered, and that's what makes the speculation so irresistible. If this fragment truly represents living quantum tech, it changes how we view civilizations beyond Earth. Because only a society millions of years ahead could create something that survives as both artifact and organism. A hybrid that can be stored as an object, yet activated as a being. But that was just part of the story. The deeper dive suggests something else. Mimicry. The data hinted that the fragment could copy scan signals and reproduce them with eerie accuracy. That means it wasn't only adapting, it was learning. Like a child repeating sounds, this fragment repeated code. In a way, the scan itself became its first conversation. So what really happened here? Did Google's quantum core accidentally wake up a sleeping intelligence?
Google's shot at regaining its edge.
So we're building a quantum computer, and that quantum computer will be able to solve problems.
Or did the fragment simply follow old embedded instructions? We can't be sure, but here's the key: the possibility of dialogue. If the fragment can mirror, then perhaps it can answer. And if it can answer, then we may not be looking at lifeless debris. We may be looking at the first glimpse of quantum communication with something alien. Zooming out, the wider implications are staggering. Imagine cities built from living quantum architecture, machines that heal like skin, networks that adapt like ecosystems. A civilization with this technology wouldn't build rockets, it would grow them. It wouldn't store knowledge in libraries, it would weave it into the fabric of its structures. Every object is alive, every tool is sentient. That raises another question. What does this mean for us? If humanity is now on the edge of such technology, are we peering into our own future? Or are we standing in the shadow of something we can't yet understand? The speculative fun here is clear, but let's ground it. Quantum computing already demonstrates today that information can behave in ways that defy normal rules. Superposition and entanglement allow bits to exist in multiple states simultaneously. Researchers at Google's quantum labs describe breakthroughs that feel closer to biology than mechanics. So, is it impossible that somewhere another intelligence took those principles and pushed them until life itself emerged from code? And here lies the chilling, thrilling possibility. The Buga Sphere fragment could be more than a relic. It could be evidence of quantum civilizations, societies that merged biology with machines to the point where the distinction between the two disappeared. And maybe, just maybe, what we scanned wasn't just an artifact, it was a survivor. So the real question now is this: are we looking at alien rubble? Or did Google's quantum core just make first contact with a living quantum system? And if that's true, what does it mean for us? The broader impact of the quantum revolution. Quantum computers were already shaking up the world with promises of solving problems classical machines could never touch. But now, this alien fragment might have forced open a door we weren't ready to walk through. If strange patterns emerge from the scan, what does that mean for cryptography, medicine, or even communication across vast distances? Could it be that the same technology designed to model molecules or optimize logistics just brushed against a signal not of this Earth? Google Quantum AI stands right at the center of this puzzle. Their quantum core is already regarded as one of the most advanced computational experiments. Paired with other projects aiming to develop practical quantum systems, it represents humanity's attempt to leap ahead by a century in capability. And yet, by placing something alien inside its reach, we may have asked the impossible question too soon. But here's the thing: every great leap comes with shadows. What happens if the fragment interferes with the delicate qubits that power the system? Quantum computers collapse from the slightest disturbance. Imagine what happens when that disturbance is not random noise, but organized information. Did we risk letting the sphere's patterns bleed into our own machines? Or worse, into the networks those machines touch? And that raises the question of ethics. Should human technology even be probing material we don't fully understand? Scientists have always balanced the pursuit of discovery with the risk of failure. Splitting the atom gave us nuclear power, but also nuclear weapons. Cracking the genome promised cures, but raised concerns about privacy. Now we're staring at a third pillar: alien-coded structures meeting human-built quantum minds. What side of history will that place us on? Of course, the optimism is undeniable. If the scan really captured alien logic, it might help us leapfrog decades of trial and error. Imagine error-free communication channels powered by principles no Earthling designed. Imagine simulations that can reveal the secrets of the universe faster than we can ask the questions. That's the kind of revolution Silicon Valley dreams of, and it just might have landed uninvited on Google's doorstep. Still, the caution is real. Technology doesn't exist in a vacuum. If something as small as a fragment can disrupt, inspire, or even communicate through a machine as fragile as a quantum processor,
development from Google that it describes as a state-of-the-art quantum computer chip,
then humanity has officially stepped into a new playing field. one where the rules are not ours alone. What Google's quantum core uncovered inside the Buga Sphere wasn't just strange data. It looked like patterns alive with intention, as if the fragment carried its own code. Not human, not a machine, something in between. And that's what makes this discovery so unsettling. If the fragment truly holds living technology, then the rules of science, and maybe even the rules of life itself, could shift overnight. Think about when microscopes first revealed microbes. Suddenly, an invisible world changed everything we knew about health and disease. This feels like that kind of turning point, only bigger. And here's what makes it even stranger. Only a quantum machine could read it. Every conventional tool failed. This raises another question. Was this fragment designed to be unlocked only by technology at a certain stage of human progress? If one fragment exists, how many more are out there? Hidden, silent, waiting. Are we standing at the edge of first contact, or at the threshold of something we're not ready to face? Share your thoughts in the comments below.